The story begins in College Park, Maryland, a quiet university town that would become the birthplace of one of the most ambitious ventures in modern science. In 2015, two physicists, Christopher Monroe of Duke University and Youngsang Kim from Korea, set out to achieve something extraordinary, to transform the intangible world of quantum mechanics into practical computation. Their goal was to build a machine capable of harnessing the fundamental behavior of nature itself, the vibration and superposition of atoms, to perform calculations that no classical computer could ever achieve. The company they founded to make this vision real was IonQ. IonQ's defining technology is known as trapped ion quantum computing. In essence, it uses lasers and electromagnetic fields to trap individual ions, charged atoms, in a suspended state and manipulate them with exquisite precision. Each ion acts as a qubit, a quantum bit that can exist in multiple states at once, unlike a traditional bit that must be either 0 or 1. This means IonQ's computers can process many computations simultaneously, rather than sequentially. It is a profound reimagining of computing itself, not just faster, but fundamentally different. At the time, the idea of commercializing such a system seemed almost impossible. Quantum computing was largely confined to national laboratories and university research groups, funded by governments or defense agencies. Private sector quantum initiatives were rare and typically limited to theoretical research or small prototypes. IonQ was the first to declare that it would not only build a working quantum computer, but also make it accessible through the cloud for commercial use. This decision alone broke precedent and marked the company's first anomaly. It wasn't just an experiment in physics, it was an experiment in capitalism, science, and imagination combined. On October 1st, 2021, IonQ went public through a merger with DMY SPAC 3, making it the first pure-play quantum computing company listed on the New York Stock Exchange. The market erupted with excitement. To many, IonQ symbolized the dawn of the quantum era, the next NVIDIA, as some analysts said, capable of defining the hardware infrastructure for the next century. The promise was monumental. Computers that could simulate molecules for drug discovery, optimize logistics for global supply chains, and secure communications against all forms of hacking. But as the months passed, a curious pattern emerged. IonQ's trajectory didn't resemble that of a typical newly listed tech firm. Normally, after going public, companies are expected to demonstrate steady quarterly growth, clear revenue milestones, and visible customer adoption. IonQ, however, was valued not for what it had achieved, but for what it promised to achieve. Its share price reflected expectation more than execution. This was the first true mystery surrounding